All right, let's jump right into this explainer. We're going to explore how humanity's future in space is rapidly shifting from the realm of science fiction into absolute reality. For decades, the whole idea of stepping beyond our own planet was basically relegated to summer blockbuster movies and high-level theoretical physics. But today, we are standing together on the precipice of a completely new era.
Just think about this wild vision for our future for a second. In 50 years, humans will walk on Mars, build cities on the moon, mine asteroids for resources. In 100 years, we'll likely launch probes to distant stars. And in 1,000 years, we might literally colonize other star systems. What you need to know right off the bat is that the technology to actually do this, it already exists. The economics are rapidly improving, and multiple private companies are aggressively racing to make this 1,000-year vision happen today.
So, let's start with Section 1, the new space economy, Earth and orbit.
To really grasp how we got here, we've got to look at the massive shift in how space exploration is funded. After 50 years of pretty stagnant government-funded space programs post-Apollo, private industry is just completely disrupting the landscape. And the catalyst for all that disruption boils down to this staggering number, $15 million. Back in 2002, Elon Musk founded SpaceX with what most people thought was an absolutely insane goal: to make rockets reusable and cheap. Everyone assumed rockets were inherently disposable, but they succeeded, and in doing so, they made this incredible price point possible.
We are literally living through a cost revolution right now. By slashing historical launch costs from $65 million all the way down to just $15 million, space has suddenly opened up for business. And because of reusability, costs are going to drop even further. We've entered an era that is honestly a lot like aviation in the 1920s. It's chaotic, it's definitely dangerous, but it's an incredibly exciting industry where companies are just rushing in to launch satellite internet, orbital mining operations, you name it.
We're also seeing the birth of an entirely new sector, space tourism. Companies like Virgin Galactic and Blue Origin are already offering these short suborbital flights for about $250,000. But looking ahead to the 2030s, we're talking about massive, rotating orbital hotels that create their own artificial gravity. I mean, deciding what to pack for a space hotel is going to be a whole different challenge, right? Now, I know what you're thinking. This sounds like it's exclusively for billionaires. And yeah, right now it totally is. But just like early air travel was only for the ultra-wealthy, this expensive early tourism is exactly what's going to fund the industry's infrastructure until space access becomes democratized and routine for the rest of us.
Okay, moving further out. Section 2, settling Moon and Mars, our cosmic neighborhood.
Before we ever get to Mars, we are heading back to the Moon. NASA's Artemis program aims to land humans back on the lunar surface around 2026 or 2027. But this lunar base isn't just for show. It's a vital stepping stone and a testing ground for long-duration space missions. From there, we are looking at the very first crewed landing on Mars, a staggering 140 million-mile, 6-month journey sometime between 2035 and 2040, and the plan is to scale that up to a self-sufficient Martian settlement of 1,000 people by 2050. Here's what's genuinely mind-blowing, though. The Moon isn't just a pit stop on the way to Mars. It is destined to support a thriving, highly profitable economy. Imagine mining water ice in the polar regions, or extracting helium-3 and rare earth elements. Even more fascinating, scientists are planning huge lunar manufacturing hubs. Things made in low gravity, like specific crystals, fiber optics, and pharmaceuticals, are vastly superior to what we can make down here. Space-based manufacturing could literally outcompete Earth-based manufacturing in the very near future.
Now you might be wondering, hey, Venus is technically closer to us, why not go there? Well, this cleanly shuts down the why not Venus debate. Venus has a surface temperature of 460 degrees Celsius, an atmospheric pressure that literally crushes metal, and oh yeah, sulfuric acid clouds. Mars, on the other hand, while extremely cold, is actually survivable. Most importantly, it has extractable water from ice, making it our absolute best and really our only viable candidate for a second home, assuming we have the right tech.
But how do we actually survive there? The first colonists are going to need to live in underground habitats just to block the cosmic radiation. From there, they'll extract water from Martian ice, grow their food in advanced greenhouses, and generate power using vast solar arrays, gradually making the colony completely independent from Earth. But the final step in this process is the most ambitious thing we've ever dreamed up: terraforming. Over the course of maybe 100 to 200 years, the ultimate goal is to thicken the Martian atmosphere and warm the planet up, eventually allowing humans to walk outside without wearing spacesuits.
Beyond the planets, there's just unbelievable wealth floating right over our heads in the asteroid belt.
Seriously, a single asteroid can contain more platinum than has ever been mined in all of human history on Earth. While the extraction technology and the transportation costs aren't quite there yet, give it 30 to 50 years, and this could be the single most profitable industry in existence. And the best part? Extracting these cheap metals in space comes with zero environmental damage to our home planet.
All right, let's step way out into the vastness of space. Section 3. Beyond our solar system, the deep space frontier.
Space is, well, it's mind-bogglingly vast. The nearest star system to us is 4.3 light-years away. To put that in perspective, that is 40 trillion kilometers. Even if you were traveling at the absolute speed of light, it would take you over 4 years. But with our current, everyday spacecraft, it would take 70,000 years just to reach our closest neighbor. Talk about the ultimate "are we there" that road trip.
Clearly, if we want to open up the broader solar system, we have to completely revolutionize how we travel. Traditional chemical rockets work, sure, but they're incredibly inefficient, mostly because they have to carry their own super heavy fuel. The real game changers? Ion drives that accelerate charged particles, or NASA's developing nuclear propulsion, which could easily cut a trip to Mars in half. We're even looking at theoretical fusion engines or warp drives that could drastically shorten travel times and give us true interstellar capability.
But even with highly advanced probes potentially reaching neighboring stars in maybe 50 to 100 years, sending humans is a completely different beast. That brings us to the theoretical, sci-fi-sounding concept of generation ships. Because an interstellar journey takes centuries, these would be massive, self-sustaining cities in space. Entire new generations of humans would be born, live their entire lives, and die in transit. All so their descendants could eventually arrive and settle a brand new star system.
But what are we actually looking for out there in the dark? We've already discovered thousands of exoplanets, many sitting right in the habitable zone. Future telescopes won't just look at them, they're going to analyze their atmospheres for biosignatures, chemical signs of life. Detecting these biosignatures would allow us to find alien life without ever actually visiting the planet, and that would finally answer humanity's oldest and most profound philosophical question: are we unique, or are we just one of many?
Okay, let's snap back to reality for a second. Section 4. The big picture. Why space matters now.
Bringing it back down to Earth, space commercialization brings up some pretty wild legal and ethical dilemmas. Think about it. Who exactly gets the profits from mining an asteroid? If we start terraforming Mars, do we risk wiping out native Martian microbes? And how in the world do we handle labor rights for people working off-planet? Currently, the Outer Space Treaty states that space is the common heritage of humanity, but enforcement is incredibly tricky, and the regulations are severely lagging behind corporate ambition right now.
Assuming we navigate all those ethical hurdles, this roadmap represents the grand trajectory of our descendants over the next few centuries. From lunar bases in the 2030s to widespread space manufacturing by the 2100s, and eventually becoming a true widespread space-faring civilization by the 2500s. But it is absolutely vital to remember that this vision assumes continued progress. A sudden halt in funding, waning political will, or some unforeseen technological barrier could entirely derail this path.
So what's the core takeaway of our explainer today? It's simple. Space isn't just a playground for billionaires. It is a vital necessity for the progression of all civilization. It solves Earth's raw material limits by giving us infinite resources. It drives incredible knowledge and spin-off technologies, things like water purification and advanced medical devices that help us out every day. It gives astronauts the overview effect, a profound perspective shift that could foster true global unity. And most importantly, it guarantees our survival.
Which brings us to my absolute favorite perspective. Space exploration is insurance for humanity. Staying confined to one single planet leaves us incredibly vulnerable. An asteroid impact, a global nuclear war, or an irreversible climate catastrophe could just end our story entirely. By becoming a multiplanetary species, we literally build resilience against global disaster.
Look, space exploration is incredibly hard. Rockets explode, missions fail. It requires a persistent, totally unwavering commitment. But that is exactly why the next 50 years will absolutely determine our legacy. We are making the choices, developing the foundational technology, and laying the groundwork right this very second. You are living during the most crucial moment in space exploration history, because what happens out there completely depends on what we choose to do right now.
So, I'm going to leave you with this lingering thought. History shows that humans are explorers by nature, right? We always push into the unknown. But this next massive leap, it isn't guaranteed. Do we have the collective willpower to see it through? Will we choose to stay earthbound,
Or will we rise to the challenge and become a true spacefaring civilization? The frontier is wide open, but the choice is entirely ours.